Alright, so we are talking about limits involving infinity here. So first question, which is going to kind of get us started, is what causes vertical asymptotes? Asymptotes, that's a place where your function approaches infinity or negative infinity. So let's look at a function here. We've got a coordinate axes, we've got an asymptote there at 2. And we'll write this down as, this is f of x equals 1 over x minus 2. So let's look and see what happens as x approaches 2 from the right. So that would be 1 over, so we're looking at close points here, so like maybe 2.1. So plugging that in for x, so 2.1 minus 2, that's going to be 0.1 in the denominator. And 1 divided by 0.1 is 10. Let's get a little bit closer here to 2. So 2.01, so really close there. Subtract 2 from that, we're going to get 1 divided by 0.01, so that's 100. And if we get really super close, so maybe at x equals 2.001, subtract 2 from that, no, it's just plug into the function here, so that's going to be 1 divided by 0.001, which is 1,000. So we can see that as x approaches 2 from the right, that ratio, the numerator divided by the denominator, is getting larger and larger and larger, and it's approaching infinity, which we can see that it clearly does there from the graph. If we look at this by plugging in numbers as x approaches 2 from the left, so that would be maybe 1.9, 1.99, 1.999. So 1.9 minus 2 is negative 0.1. 1 divided by negative 0.1 is negative 10. If we're at 1.99 minus 2, then that's going to give us negative 0.01, which is negative 100. 1 divided by that number. If we get really close, 1.999, subtract 2 from that, and we get 1 over 0.001, and that's negative 1,000. As we can see here, as x approaches 2 from the left, this ratio is approaching negative infinity, which we can see the graph agrees with that. So if our denominator here in a rational function, so in like a ratio, if that denominator approaches 0, which we have it approaching 0 here, and here we have approaching 0 here, then the ratio will approach either plus or minus infinity. All right, so that's we kind of see we might get some infinite limits there. So we get the. Let's talk about some other infinity and limit situations. Now this is a little bit different. Here we have a rational function, but I'm saying what is the limit of 3x squared plus 2x over x plus 7 as x approaches infinity? So as x gets larger and larger and larger, let's just think about this. Okay, it's going to end up being 3 times some really large number, I'll just put infinity squared, plus 2 times really large numbers, which is infinity, divided by infinity plus 7. So lots of large numbers in the numerator, lots of large numbers in denominator. So is this something like an infinity over infinity, which would cancel each other out as 1? What's going on here? No, by the way, the answer is that is not the answer. But this just makes us wonder what's really going on and makes us think we need to maybe perhaps think about this a little bit deeper. So that's not totally correct, actually. So here's a question that maybe is a little bit better. You know, we had a jump from this step to this step where we said 3 times infinity squared plus 2 times infinity. Well, that's just infinity, and it's an equal value of infinity as infinity plus 7. When, in fact, this number up here is growing quite quickly, and so we'll ask the question, which grows faster, 3x squared plus 2x or x plus 7? And if you're familiar with the shape of quadratics and the shape of linear functions, you know that the quadratic is going to expand faster. It's going to grow faster, anything x squared, regardless of whether it's times 3 or not. So the 3x squared plus 7, that's a mistype there. I should have put 2x. I'm not sure why that is there. But anyway, so yeah, the 3x squared, that quadratic term, the one in the numerator, that is going to grow faster than the denominator. In fact, 3x squared plus 2x, we can pretty much approximate that as 3x squared, because, especially as x gets larger and larger, because the 2x really doesn't do anything. It doesn't hardly compare at all to the 3x squared. That x squared is like totally dominant. So we're just really going to completely ignore those lesser powers of x here. And the same thing for the denominator. You've got an x and a 7. Well, the 7's not growing at all. So x plus 7, we really can just sort of approximate that as x. So let's look at this with these thoughts. So it's the limit as x approaches infinity of 3x squared plus blah blah blah, who cares, divided by x plus blah blah blah, who really cares, because this is the dominant term in each one of them. The highest, the term that has the highest exponent as it relates to x. So if this numerator is growing faster than the denominator, which that's what we're saying, let's see what happens. So I'm going to just throw some numbers here, a couple of different ratios, where we're going to see what happens with this division, with this ratio, as the numerator grows faster. So here's a 5 over 2, and then a 10 over 3. As you can see, this has gone up by 5. The numerator's gone up by 5, but the denominator's only gone up by 1. Then 20 over 4, so you can see we're going up we're doubling here. The numerator, the denominator is just going up by 1. Then, 30 over 5. So let's see what these ratios turn out to be. So 5 halves is 2.5. 10 thirds is 3.3. 20 over 4 is 5. 20 over 4 is 5. 30 over 5 is 6. So this fraction is getting bigger, and in fact it's going to continue to get bigger. It's going to approach infinity. So if that numerator wins, so to speak, if that numerator is growing faster than the denominator, then that ratio is going to approach infinity. Side note, it's actually going to be positive infinity or sometimes negative infinity, and we'll talk about that here momentarily. But before we talk about that, let's flip things around. What if they're switched? What if the denominator grows faster than the numerator? Okay, well, I'll do the same sort of example, but I'm just going to do the reciprocal of all of these. So 2 over 5, 3 over 10, 4 over 20, 5 over 30. And let's go ahead and do that division. We get 0.4, then we get 0.33, then we get 0.2, then we get 0.16. So we're going down, and definitely seem to be approaching 0. You might ask yourself, are we ever going to go negative? And the answer is no, because these numbers are all positive. I'm doing 2, 3, 4, 5. I'm going up. So positive numbers in the numerator, positive numbers in the denominator. I'm always going to have a positive over a positive. So it's always going to be positive in terms of the division. The quotient is going to be positive. It's just going to get closer and closer to 0. And notice this is the denominator growing faster than the numerator. So approach 0. So final question, sort of like the third scenario. What if they grow at the same rate? Like, for instance, that is, the numerator and denominator have matching highest power of x. So here's an example. Oh, actually, I'm going to give you the answer. It's the ratio approaches the ratio of the leading coefficients, where the leading coefficients are defined as the coefficients in front of the highest power of x. So an example of that might be if you had the limit as x approaches infinity of 3x squared plus 5x divided by 7x squared plus 8x. So we look up here, the highest power of x is 3x squared. The highest power, or the term with the highest power of x is 7x squared. So those other parts really don't matter. Those twos, they tie. Tie goes to the runner. Well, actually, tie goes to the coefficients. 3 over 7. There we go. I know you're wanting this, so here it is, way down deep in the video here. A nice little summary statement. So here we go. The limit of ax to the n plus a whole bunch of other stuff over bx to the d. I've got that, so this is the exponent in the numerator and this in the denominator as x approaches infinity. Well, if the numerator exponent is bigger than the denominator exponent, then we approach infinity. Technically, plus or minus infinity. And I'm going to clean that up a little bit. If the denominator is bigger than the numerator, or numerator less than the denominator, then we approach 0. You kind of think of it as like the denominator swallows it up, and it approaches 0. If they are equal, then it's going to be the ratio of those leading coefficients, which I have labeled here as A and B. All right, that's great. We're happy and excited about that. So let's deal with that whole plus or minus thing. So if the numerator is bigger and we approach infinity, we've got to watch out for negatives. Let me show you what I'm talking about. Sometimes you might have a problem that says the limit as x approaches negative infinity of 4x cubed plus 2x over, say, x squared plus 7x. Now, we look at this and we see the numerator exponent is 3, the denominator exponent on the x term is 2. So clearly the numerator wins, clearly it's going to be infinity. However, looking at this term here, you can kind of think about, as we're getting larger and larger, that this would be like a negative infinity cubed, which would be like a negative times a negative times a negative, which 3 negatives multiplied together are going to equal another negative. So that term in the numerator is always going to be negative. Since now I remember we're kind of ignoring this right here, but this term right here, as x approaches negative infinity, 4x cubed is going to be negative. In the denominator, however, as x approaches negative infinity, x squared is always going to be a positive term. So you will always have a positive term in the denominator. Therefore, since you will always have a negative term in the numerator and a positive term in the denominator, it will always be a negative divided by a positive, which is that's right, negative. So this ratio actually approaches negative infinity. And that's the correct answer, negative infinity. So it really boils down to whether or not you've got even or odd powers of x. Here I have 4x cubed plus 2x as x, and then I have x plus 7. So here, previous problem, x squared, now I have x. We've got a 3 and then a 1. Clearly the 3 is larger than the 1, so we know that this ratio is approaching infinity. The only question is it going to approach positive infinity or negative infinity? So in the numerator, it's still same sort of analysis. Negative infinity cubed is going to give you a negative infinity number. The denominator, however, is going to be just negative infinity. So now we have a negative over a negative, which is a positive. So the answer here is positive infinity. All right. Let's look at one more example. So here we have the limit as x approaches negative infinity, 4x to the 6th. So we're changing that, and x to the 4th down here. So obviously dominant terms I have listed first. We have an x to the 6th, then x to the 4th. X to the 6th is going to win. Negative infinity to the 6th is going to give a positive infinity number, and negative infinity to the 4th also a positive infinity. So positive over positive is a positive. All right. So lastly, just a heads up, sometimes, you are going to have multiple negative situations. So there might be like a negative stuck out in front of this whole term, which if there's a negative now in front, then that's going to change whatever sign we would have here otherwise. So that would have made that positive here. It's like you had a negative in front of the whole thing. So you do all that analysis and then you just multiply by the negative. The same thing down here. If there's a negative out front here, we would do all that analysis and then that positive would turn into a negative. Sometimes you even have the negative in front of just like one of the single terms, and that's fine. This x to the 6th would still be positive, but then it would be multiplied by a negative 4. So the numerator would be a negative, the denominator would be positive, and a negative over positive is a negative. All right. So let's go ahead and look at some problems real quickly. So here we've got a graph, and that's great. This is the limit of g of x as x approaches negative 3 from the left. So here's negative 3, and let's approach it from the left. And looks like we're hitting the y value of negative 2. So then we do the same analysis from the right. So approaching it, and the line is marching up here towards infinity. So we've got infinity. And since the left and right sided limits do not agree, then the two-sided limit does not exist, DNE. This one's just same kind of stuff, but I guess we'll look at here. Approaching 2 from the right, infinity. Approaching 2 from the left, infinity. Two-sided limit, infinity. We like that. You might run into also some limit problems where they don't give you the graph. Oh no. We're like, oh man. Desmos can graph that though, and that makes us happy because you can just type in that function and then look at the graph and then figure out what happens as we approach 5 from the left, 5 from the right, and then obviously the two-sided limit. And you could do the same thing there. So let's move on to our final problem type here, and that is a limit evaluated as x approaches plus or minus infinity. So they're trying to be tricky here. They're not like me, where I always am nice and write the polynomials in order of decreasing coefficients. They have the negative 5x right here, and then a 7x squared down there. So clearly the denominator is going to win, and if the denominator wins, we approach 0. This one here, we have a numerator power of 3, denominator power of 2, so we know absolutely numerator is going to win. We're going to approach infinity. The only question is it going to be positive or negative infinity? So looking at the 3 there, this is positive infinity, so that's going to be a positive infinity right there. But this negative right here is multiplied by it. The denominator is all positive, so it's a negative divided by a positive, which is a negative infinity. There we go. One more. So we have x approaches negative infinity, so we're going to be extra cautious here. Numerator negative 3x squared, denominator negative 4x. So numerator is definitely going to win, which means we've got a plus or minus infinity situation. Now just got to do some more analysis to figure out which one it is. So this minus right here, I'm sticking right there to keep track of, and then the x squared I'll write as negative infinity squared. So anything squared turns into positive, and then this negative, however, up front makes that numerator term negative. So we have a negative in the numerator all the time. The denominator, we have a negative 4, we'll just ignore the 4 for most part here, and the x is being replaced with negative infinity. So negative times a negative is going to give us a positive. So negative divided by a positive is a negative. Negative at infinity is the answer there. Hope you were able to follow that. And then part B, we have negative 4x squared, and the denominator negative 7x squared. So we've got a tie. So that's going to go to the coefficients. The coefficient here is negative 4. The coefficient here is negative 7. Now remember, we're always looking for the highest term, and that's these right here. Negative 4 over negative 7 can reduce to 4 over 7. And there we go.